Alright, so I was interrupted in the middle of my video, so that's why I'm wearing different clothes, because it's a different day. But after we do our derivative rule for the product of dy over du times du over dx, we will end up with this. Notice I did my u substitution when I went and wrote my final answer. We do not want two variables in our final answer. And then it's just a matter of cleanup. So we've got to multiply together this 2x and 3 out here. Technically these parentheses can just drop. And so we end up with 6x. We also need to go ahead and double distribute this quantity squared. And so we'll end up with x to the 4th plus 2x squared plus 1. And again, if you're not good at double distributing, you need to do that work off to the side over here. And then our very last step in this algebraic cleanup is to distribute the 6x to the parentheses, and we will be done. So the derivative, dy over dx, is 6x to the 5th plus 12x to the 3rd plus 6x. Now that was so much easier than if we would have had to cube this quantity, because we would have had to double distribute and then triple distribute and then do the derivative. But instead we were able to use u substitution, identify our pieces in our composite function, do the derivative of each, and then just simply multiply du over dx times dy over du. And there we go. Now let's go ahead and do another example. And for this one, let's do a square root. So say we have to find dy over dx for f of x equals the cube root of the quantity x squared minus 1 squared. Ooh, what a yucky mess, or at least it appears that way. So this time, instead of using the u substitution method and the dy over du, this time let's find it using this rule. Now these rules are really one and the same, but one way may click with you better than the other. So in this particular problem, we are going to identify our f of x and our g of x. And so our innermost function is going to be our g of x. And hopefully you can see here that our innermost function is this x squared minus 1. So that's going to be our g of x, the x squared minus 1. And then our f of g of x is I'm trying to notate this in a way that makes sense. The cube root of, and in this place I'm still going to end up using the u substitution. So this, how I do that doesn't really make no sense. I don't know how to notate it properly, I guess I would say. So I'm just going to go back and say we're going to use the u substitution. So this is our u, and this is our f of u. And now we're going to do the derivative of each one. So our du over dx is 2x. Doing that derivative is pretty easy. And then this whole thing. I should just do it the notation that I'm used to. This whole thing is going to be dy over du equals. Now before we can actually do the derivative, this is supposed to be in power rule form. It's got a radical, so we need to change that to become u to the 2/3 power. Hopefully you know how those radicals change like that. If you don't, ask me in class tomorrow. And then we do the derivative from this. So we're going to use that power rule. 2/3 comes out front. And we reduce the power by 1, which will give us negative 1/3. So our derivative, dy over du, is technically 2 over 3 times u to the 1/3. And keep in mind, u to the 1/3 is the same as a cube root. So now we go and we actually apply this rule. Dy over du times du over dx is equal to our derivative. So we're going to say dy over dx equals, and we're going to multiply this and this. So we'll have 2x times 2 over 3 cube roots of, and now we need to do that u substitution back. When we write our final answer, we don't want a u there. Instead, we want to have what u was originally equal to, which is x squared minus 1. And then it's just a matter of cleaning it up a bit. So we're going to call this dy over dx equals 4x over 3 cube roots of x squared minus 1. Now, can we rationalize? Yes. Are we going to? No. I've given up on the idea of trying to rationalize a lot of these problems because the more I look in the textbook that I'm working with, the more I see that they just leave answers like this. And they just let it be. So it's not a big deal. We're not going to rationalize it. And that is our final answer.